Hello guys and welcome to JAMB Chemistry class. And today we are going to be looking at Dalton's atomic theory as evidence on the board. Please do note that this video tutorial can be used for WAEC purposes, for JAMB, for WAEC, for NECO, even for GCE as you prepare for any exam in Nigeria. All right, this will be a series of videos as we seek to look at the atomic structure. We're going to look at John Joseph Thomson's model of the atom, look at Ernest Rutherford's model. We're going to look at Neil Bohr's model. That will make us fully have a grasp or understanding about the atomic structure. Please do know that there are so many episodes in JAMB Chemistry. This is not the first, so please do well to go back to them, watch them, answer questions on them, and get yourself ready for JAMB examination. All right, as we begin today, Democritus is a Greek scientist in the 4th century. He was the first to suggest atoms. But most of the earliest understanding about atoms were largely due to the effort of the man called John Dalton. John Dalton, who lived from the year 1766 to the year 1844. He summed up most of his findings in what we now know to be called Dalton's atomic theory. So we're going to be looking at Dalton's atomic theory today, and then we're going to look at the drawbacks to the theory Dalton postulated. Then, of course, the drawbacks or the modification, and then we'll be done with this class. It's not going to be too long so that it doesn't bore you. So because of time, I'm going to head to it immediately. All right. So John Dalton proposed his theory in the year 1808. 1808. He proposed a theory in the year 1808, and he used his theory to explain the laws of conservation of mass, law of conservation of mass, and then the law of definite proportion. He used his theory to explain the law of what? Conservation of mass and the law of definite proportion. All right. What did this law state? What did he postulate? And what were the drawbacks and the modifications? Let's get to it right away. Number one, John Dalton said that matter is discrete. His first theory, he said matter is discrete and made up of very tiny particles called atoms. Number one, he said matter is discrete. When they say discrete, they mean discontinuous and made up of very small particles called atoms. When he made this statement, it didn't end there. He went further to say that an atom is the smallest particle of an element that can take part in a chemical reaction. All right, so this was the first postulate of John Dalton. He said matter is discrete, that is, it is discontinuous and made up of very small particles called atoms. And he went further to say an atom is the smallest, there's an error here, is the smallest indivisible particle. Indivisible. indivisible particle of an element that can take part in a chemical reaction. All right, so this was the first postulate he made. Then number two, he said that atoms can neither be created nor destroyed in a chemical change. All right, so number two is say atoms can neither be created nor destroyed in a chemical change. So number three, the third postulate he made, let's look at number three. We're going to look at all of them, and then we're going to look at the modifications he made to them, that the later scientists made to them, because he wasn't the one that made the modifications. All right, so number three, he said atoms of the same elements are identical in all respects, having the same size, shape, structure, and especially mass. All right, so you say atoms of what? The same elements are identical. Atoms of the same element they resemble well, are identical in all regards, in all respects, in all aspects, having the same size, shape, structure, and especially mass. This was the the third postulate what John Dalton made. Now let's look at the fourth one, number four. Of course, he said atoms of different elements have different properties and masses. All right, so atoms of the same element are identical in all respects, having the same size, shape, structure, and mass. However, the fourth postulate said atoms of different elements now have different properties and masses. All right, so now we'll go to the fifth postulate, which is said atoms of different elements combine in a fixed ratio of small whole numbers, in a fixed ratio of small whole numbers to form compounds. All right, it said atoms of different elements combine in a fixed ratio of small whole numbers. I think this is the main point here, of small whole numbers to form what? Compounds. Such as two elements can combine together to form what? A compound, right? Hydrogen and oxygen combine in simple ratios to what? To form what? To form water. Of course, sodium and chlorine can combine in simple ratios to form what? Sodium chloride, NaCl. Right? So he's saying this was what he postulated. Atoms of different elements combine in a fixed ratio of small whole numbers to form compounds. So now let's look at the sixth postulate. And of course, the sixth postulate is saying that atoms of the same elements, I'm so sorry that this could not all be in one board, right? Six said atoms of the same elements, can combine in more than one ratio to form to form more than one compound. All right. So it's saying that what atoms of the same element can combine in more than one ratio to form more than one compound. Atoms of the same element can combine in more than one ratio to form more than one compound. It's as simple as it is written. Please, if you want to get a fuller understanding about this, please go back to what our video on laws of chemical combination, and then what make sure you listen to that video, watch that video, and fully understand it. It's on this channel. Do not forget to go back to it and watch it. So number 7, which is the last one, he said all chemical changes result from the combination or separation of atoms. All right. He said all chemical changes result from the combination or separation of atoms. So these are the 7 postulates that John Dalton made in the year 1808, which he used to explain the laws of chemical combination and the laws of definite proportion or constant composition, rather the laws of conservation of mass, rather, and the laws of definite proportion or constant composition. All right, having seen these theories, you see that John Dalton's theory formed a framework. It formed a framework that could later be explained, that could be explained by later scientists. So scientists that came after John Dalton were able to explain these theories better. They could be able to modify these theories and explain it in a more better way. But of course, John Dalton was there before any of them, and that is why John Dalton is widely regarded as the father of modern atomic theory. So John Dalton is widely regarded as the father of atomic theory. So despite the success of the postulates of John Dalton, there were some drawbacks. There were some modifications that were now made by later scientists. All right, so we're now going to look at the modifications that were made. Because of time, I will not need to write the theory again, because it is from this theory we are going to list the modifications. So I'm not going to write the theory on the board again. I'm going to state it, then just drop some hints on the board about the modification, some important aspects of the modification. All right, so number 1, of course, you remember the first theory that John Dalton postulated. He said matter is discrete, that is discontinuous, and made up of very small particles called atoms. He went further to say that an atom is the smallest indivisible particle of an element that can take part in a chemical change or in a chemical reaction, right? So of course, present knowledge has made us to know that an atom can still be further subdivided into elementary entities, such as protons, such as neutrons, and such as electrons. All right, so atoms can still be further subdivided into elementary entities such as protons, neutrons, and electrons. And this was made known by John Joseph Thomson, J.J. Thomson, in the year 1897. So he was one that modified that theory of John Dalton, that an atom is the smallest indivisible particle of an element. An atom has been known to be further subdivided into elementary entities such as protons, neutrons, and electrons. So of course, let's go to the other. That is the first modifications to the theory. Now let's look at the second modification. Number 2 law states is always it's always constant, it's always there. So atoms can neither be created nor destroyed in a chemical reaction. That one is very, very correct, because it corresponds with law of conservation of mass. All right, then it said atoms of the same element are alike in all respect, or they are identical in all respect, having the same size, shape, structure, and especially what mass. But of course, it is now made to know that atoms what exist, elements exist whose atoms, an element what exists whose atoms what have what slightly different what masses, right? So of course you can see from the isotopes of what of hydrogen, we have protium atom. While the protium atom, we have the deuterium atom. Then we have what the tritium atom. Why this is what atomic number one, mass number one. This is what atomic number what one, mass number two. This is what atomic number what one, mass number what three. So you can say atoms exist here whose what or element exists here, an element exists whose atom have what slightly different masses. So the discovery of isotopy, a phenomenon whereby an element can have the same atomic number the different mass number, has helped debunk or has helped modify that theory of John Dalton, that atoms of the same element are identical in all respects, having the same size, shape, structure, and what, and especially what mass. All right. So of course, let's go to another theory that was modified. He said what atoms of different elements have different properties and what and masses, right? So of course, another phenomenon called isobars. Isobars. This is what isotopes, right? So these are isotopes of hydrogen, right? Protium, deuterium, and tritium, right? You can see them having what the same atomic number but slightly different what masses. So isobars also is another isobarism is another what phenomenon, right? So this is what isotopy, this is what isobarism, right? So isobarism is a phenomenon whereby different elements have what the same mass. Different elements having what the same mass. So it's possible for what for two or three elements to have what the same mass but different atomic number. So different atomic number, but what? But the same mass. In case of isotopy, we're having what? The same atomic number, but different masses. Here we're having what? Different atomic number, but what? But the same what mass. So of course, the discovery of isobarism has helped to debunk or modify that theory that what that different atoms of different elements have different properties and what and masses, right? So if you see an example of isobars, if you see argon, potassium, and calcium. This is 18th element. This is 19th element. This is the 20th element. Mass number is atomic mass number is 40. Mass number is 40. Mass number is 40. Right. So these are what? These are isobars. So the discovery of isobarism has helped to modify that theory that John Dalton stated when he said that atoms of different elements have different what properties and mass. Now, what that now brings us to the last modification. When, of course, John Dalton stated that what atoms of what of different elements can combine in a fixed ratio, of small whole numbers, fixed ratio of small whole numbers. A fixed ratio of small whole numbers to form what? Compounds. Isn't it? We remember quite well. So please go back to the video. You can take it back, understand, know the theories on your head. Know them. They're very easy to understand. Then, so that I can know what the modification that we made to them. So he said what? Atoms of what? Of different elements can combine in a fixed ratio of small whole numbers to form what? To form compounds. But of course, atoms of complex carbohydrates, atoms of complex carbohydrates, proteins, and lipids, they do not combine in what? In small whole numbers at all. They do not combine in small whole numbers at all. Example, you see an atom like chlorooctadecane, right? Having a chemical formula of what? C18 H37Cl. You can see that what? That the atoms of what? Of carbon, hydrogen, and chlorine here, they do not combine in what? In small whole numbers at all. You can see C is here is 18 ratio what? 37 ratio what? Ratio 1. So these are not what? Small whole numbers at all. And that is why this modification was made to what? To John Dalton's what theory, when he said what? Atoms of what? Different elements can combine in a fixed ratio of small whole numbers to form what? To form compounds. So the atoms of complex carbohydrate, proteins, and lipids, they are not in small numbers at all. Neither is this one that we just looked at. So these are the modifications that we made. And please, what you should know about this class, very important point you should know the theory of John Dalton. Know the theory he postulated. You'll be asked questions on that. All right. So for revision's sake, for you to be able to practice, of course, download the O3Schools JAMB app. Of course, do not forget that this video is brought to you by O3Schools JAMB app. All right. So you can download the app, search for 2002 number 23. Right, this is a question on John Dalton's atomic theory. It was also repeated in the year 2020, question number 2. For those of you that say, does JAMB repeat past question? Of course they do. They do. That's why you need a credible app like the O3Schools JAMB app for you to be able to ace your exam. So download the app from Play Store, activate for just 2,500 naira, and do not forget to subscribe to this YouTube channel. Subscription to this channel is free, totally free. Just click on this red subscribe button below this video, and of course you can click the like button. Please click the like button so that others can easily find our video, and you can share to your WhatsApp group, to your Facebook group, to your class group, wherever, so that they can also learn and join us in this journey to have a very high JAMB score. So this is where we're going to end the class for today. The next class I'm going to be having, of course, is a sequel to this one. See you in the next class. My name remains Owolabi Thank God, aka MC Owoblo.